So let's start the next session. So previous session we discussed about align edge. Sorry. So we discussed about set edge. So we discussed about set edge, right? So in set edge, we will locate one edge, right? And then we will set the x, y, and z0. So next we are going to discuss what is align edge. So align edge means, suppose you have a workpiece, right? Suppose you have a workpiece. Here we will calculate the angle. Find the angle, and based on that, we will be able to align the coordinate system. Whether we will be checking whether the workpiece is parallel or not, or it's tilting. So there will be an angle, right? So based on that angle, we will align the coordinate system. That is what is called the align edge. Say, for example, consider a workpiece, and the workpiece is like inclined like this, say approximately 2 degree or 5 degree inclination. If this is the case, and if we run our program, the workpiece is tilted with an inclination, right? If we run this program, we will not get the required shape. So in that situation, we will use align edge function, and then we will find that angle, and then based on that angle, we will correct the coordinate system. So in what scenario we will use this? So the scenario is, suppose your workpiece is not properly clamped properly. There is a small inclination. Or if the part is from casting or forging part, or the part is an irregular workpiece, or if there will be a small angle in the vise. So the procedure will be like this. First of all, select the job mode, right? Select the job mode and measure the workpiece. Then select the align workpiece option, align edge option. Again, when you select this, you have three options. One is measure only, 0 point offset, and point of reference. Measure only means it will shows the angle. 0 point offset means that value you can store in G54, G55, etc. Reference point is it will save the reference point only. So normally in our case, we will use this one, 0 point offset. And after that, you have to select the direction, measurement direction. So plus x, minus x plus y minus y. Then after that, select the work offset, G54 or G55, G56. You can select the correct work offset and then give the reference angle and then give the reference angle. Normally in the drawing, if the edge is 0 degree, reference angle will be is equal to 0 degree. Then after that, you have to select point number P1. That means you should move the tool to reach the first point P1. Okay. And then after that, you can save that as P1. Save P1. Then after that, you have to select the second point. That means P2. Second measurement point P2. Okay. So you have one edge. So that same edge move to another location. Then save P2. Okay. So ensure that these two places are not in the same location, same point. Okay. If you define P1 and P2 same location, you will get an error message. Then after that, just press apply. So then machine will calculate the distance. Machine will measure what is the distance between this P1 and P2. Then it will calculate the angle. Then inside the G54, it will store. It will store in the rotation. So we discussed rotation, scaling, mirroring, etc. Right? So this angle will stored in the rotation in G54. Say, let's take one example. Okay. So if the workpiece inclination is a 3-degree inclination. Okay. If you use align edge, so this is one edge, right? So this is P1 and this is P2. So rotation is equal to 3 degree. And this 3 degree is stored in G54. So then we will run the program. It will consider this 3 degree and then it will properly listen the workpiece. This is what is called the align edge. So what is the difference between align edge and set edge? In align edge, we will use 2 points, right? In set edge, we will measure only one edge. Here, we will measure a 0 point plus angle alignment. This align edge is used when the workpiece is tilted. Set edge is using when the workpiece is parallel. When the workpiece is parallel. So I have mentioned P1 and P2, then save. Okay, then set work offset. Then coming to the next one is called a rectangular corner. Rectangular corner. So what is a rectangular corner? So we have a workpiece, right? We have a rectangular workpiece. Okay. It will clamp in the vise, but it is not parallel to, XY axis. Not parallel to XY axis. So here, machine should know where is the corner, how much will be the inclination of the workpiece. So using this, we can identify the corner and also its inclination. So this rectangular corner will calculate the three important things. Okay, 3 points will be measured, right? First one is the corner position. So in this case, 3 points will be measuring. One is corner position. Okay, corner position means what is the X and Y value of that particular position. Then what is the workpiece angle? And then third one, G54, work offset. So when you will use this function, if the workpiece is not clamping properly, there is a small inclination. Okay, and you can use this in a rectangular or square block. If your fixture will affect a small angle, and also you will be you need the coordinates of x0, y0. Again, the procedure will be go to the job mode, right? And then after that, measure the workpiece. And after that, select the rectangular corner. Again, when you select the rectangular corner, you have three options: measure only, 0 point offset, and point of reference. So as you already know that measurement option will only simply measure, it will not say. We need 0 point offset, it will say inside the V54. So we will be using this commonly reference point. Point of reference means it will store the reference point only. Then after this, you have to find the external corner or internal corner. Next we need external corner or internal corner. Then select the corner position. Position 1 to position 4. Okay. Position 1 to position 4. For example, left bottom position 4, left top position 1, right top position 2, right bottom position 3. Then measure only, calculate. It will show the machine values. If you select the if you select the 0 point offset, select the offset G54 or G55, then click apply. By checking the drawing, X0, Y0, Z0, give 0, 0, 0. Now measurement is going to start. First point P1. Okay, edge one edge touch, save that as P1. So first point as P1, and then touch another edge, save it as P2. Then third point as P3, and then make sure that these 3 points will be different locations. Otherwise, machine will show error. Then after that, apply. After that, apply. So machine will calculate the corner, calculate the angle, and it will update in G55. So as I have mentioned, save P1, save P2, and save P3. Then after that, machine will calculate the corner angle and it will update in G54. So when we compare the three options, three functions we discussed, one is set edge, right? And the second one is align edge, and the third one is rectangular corner. So what is the difference? In set edge, for example, we will use 1 point only, right? And in align edge, we will use 2 points, P1 and P2. But in rectangular corner, we will be using 3 points, P1, P2, and P3. Okay. Then coming to the next function, hole. So coming to the next function, suppose you have a workpiece. Okay, suppose you have a workpiece and the workpiece contains a hole. Okay, so machine don't know. Hole means there is a center, right? There is a center, and also hole means there is a diameter. So machine don't know where is the center of this hole and what will be the diameter of this hole. So hole function will find where is the center of this hole and what will be the diameter of this hole. So in what case or in what situation you will use this option to identify the center of hole? Okay, you have a circular hole. You need to find where is the center of this hole. Or you will machine based on existing hole as the reference. In that case, you will use this hole option. And also, in some cases, you need to set this hole center as the origin. That means G54 to set the offset. How you will fix this point as the origin G54? How you will set? You need this option, hole option. And also in this way, you can calculate what is the diameter of this hole. Right? In these different scenarios, you can use this hole option. Hole option. So similar to the previous case, here we will be considering, in the previous rectangular corner, we will be considering 3 points, right? But in this hole, we will be using 4 points, P1, P2, and P3 and P4. So using these 4 points, using these 4 points, machine will calculate the circle. Suppose there is a circle like this. Okay. So here P1 will be here, then P2, P3, and P4. So using 4 points. So machine will use these 4 points to calculate what is the center of this circle and what is the diameter of this circle. Okay, so let's see the procedure. Again, the procedure will be same. Go to job mode. Then after that, select the measure workpiece. Then select the hole option. And then after that, select the measurement option. Again, if you select the measurement option, you have 3 options. Select measure only, 0 point offset, and point of reference. So we will be using the second one, 0 point offset, so that we can save this into G54 or G55, etc. So after calculating, it will shows where is the center and what is the diameter. So we will measure. So go to the next point. So we will measure P1, P2, P3, and P4. Okay, and save. And again, similar to the previous cases, these 4 locations will be different locations. Okay, otherwise machine will shows an error. And after that, you can set the work offset. So the machine will calculate what will be the diameter of the hole and where is the center of that hole. So machine will be calculating the hole center. Hole center means, for example, so we have a hole, right? This is the center, right? So this center means hole where hole x value, hole center x value, hole center y value, and the diameter and the work offset. So these are the four options, four things machine will calculate. So where we will use the situation. Suppose you have a, you can think about a practical use in industry. You have a plate, okay? In that plate, we have a hole. Now you are going to start a new machining, and you will be starting the new machining from the center of this hole. Okay, that means you have to set G54 here, right? So in that case, you will use hole function to find the center of this hole and save this point to the there, to the G54. After that, you can run the program. So, so we have discussed four different functions. One is set edge, right? And after that, we discussed align edge, right? Then we discussed the rectangular corner, and next one is one hole, right? So think about how many points we will be using. In set edge, we will be using only 1 point. Align edge, we will be using 2 points. Rectangular corner, 3 points. But in one hole, we will be using 4. So what is the benefit of this? You can find the hole, center, and the diameter. In rectangular corner, you can find the corner plus angle. In align edge, you can find the angle. Here, you will be setting 0 based on one edge, right? Okay. So next is one circular spigot. Okay. So in the previous case, one hole means there is one circular shaped hole, right? It will measure the, suppose this is the workpiece, right? We have a hole, right? So one hole means it will measure this hole, right? But one circular spigot means you have the workpiece, right? Okay. So we have a boss like this, see this extended. So one circular spigot will measure this boss or spigot. It will measure the boss or spigot. So circular spigot means extending some portion uh, outside. Okay. So for example, I will show you the side view. Okay. So just imagine this is the side view. Okay. You have the workpiece. When you look from the side view, you can see the some portion will be extended like this. This is what is called a circular spigot. And this portion is what is called a circular spigot. This is called a circular spigot. If you look from the top, you will see two circles only, right? But if you look from the side view, then only you can see this extended portion, right? Okay, similar to the whole option. Here also you need to calculate the so you need to calculate the center xy and what will be the diameter. What will be the diameter of this? So where you will use this option? So this function will be used. You have a shaft boss, circular boss, locator pin, cylindrical projection, round feet. We find the center of a round feature. Again, similar to the previous case, we will be using 4 points, P1, P2, P3, and P4. Measure 4 different points, and using these four points, machine will calculate the sender and the diameter, and it will store inside where inside G54 or any other work offset. So next is what is called as spacing two edges. What do you mean by spacing two edges? Spacing two edges means you have a workpiece like this. Okay, and you have edge one and edge two. So machine don't know where is edge one, where is edge two. Machine don't know where is this edge one, where is this edge two. Okay, and also machine don't know where is the center of this two edges. Machine don't know. So to find edge one, edge two, and the center, we can use this spacing two edges option. So this function will be using to find the center of the workpiece. So using this, we can find the center of the workpiece. Okay, using this option, we can find exactly the center of this option. Suppose you have a plate, okay, plate clamped on the vise. Okay, now you are going to calculate the center of this plate. Okay, so you can use this option, spacing two edges, or sometimes you need to find what is the distance between two parallel faces. Okay, you have a plate, you need to measure what is the distance between these two parallel faces. So you can use this spacing two edges option to find this, and also for fixture alignment. Okay, just imagine, suppose you have a block of say 100 mm. Okay, so 100 mm means this one we can say this is x0 and this is x is equal to 100, right? Okay, and the center will be how much? And the center will be 50, right? So machine will measure the left edge, right? And machine will measure the right edge, and machine will calculate this. The center will be equal to 50 millimeter. So the procedure will be same. Okay, go to job mode, and then after that measure workpiece, you should select spacing two edges option. Again, when you select this, you have measure only option, zero offset option, and the basic reference. So every time we will use the second one only. Okay, right? Because our aim is to save that offset to G54 or 55, 56, 57, etc. Okay, once select measure only calculate, it will show the machine distance. If you select G54, we can save that value to the G54. Reference angle will be 0 degree. Reference angle will be 0 degree. Okay. Here also, again, the procedure will be like this. First, measure point P1. So first measure point P1. Okay. So move the tool and touch one edge and save that as P1. Then move the tool to a safer position. And then after that, touch to second edge and save that as P2. And again, make sure that P1 and P2 will be different locations. So machine, so you have P1, so this is P1 and this is P2, right? Then after that, machine will calculate what will be the distance between these two edges, and also machine will calculate the center position. If required, machine will calculate the angle, and it will update in where? It will update in G54. It will update in G54. So let's take a simple example so that you can easily understand. Suppose you have an aluminum plate. Okay, suppose you have an aluminum plate, and the width of this plate is equal to 120 millimeter. Okay, so this one will be P1 and this one will be P2. Okay, so machine will calculate this distance as 120 and the center will be 60 millimeter. So this value will be stored in where? This value will be stored in G54. So we will see one by one. Okay, so let's try this one, spacing toward this object to find the center, right? So, so go to menu select parameter for offset. Okay, then so save P1 and P2. So save P1 and P2 and select our box. This is this and that. This represents this and that. This represents. It will be y, y, three y. Because it's maybe plus five, yeah, minus zero. Instead of then plus then zero and minus zero. Now you can go to the option. You can take the you can see what is the right? So you prepare your house store, right? So that will be the sender of this. So that we can run the program, we have a program, right? And first of all, I will do half the time website. So I will change this to okay, so I will change this to so my Similar to that, you have this one. Okay. So here you have to select P1 and P2. That this is for a circular hole. Okay. And you have to select 4 fans. And this is for this. We call it as spigot. Okay. We call it as spigot. Same way, select 4 points and we can store that value into the offset. So, so these are the 6 options to set the offset using manually. The next we are going to discuss how we can set the offset using measuring probe. So next, I'm going to discuss automatic measurement of workpiece zero with measuring probe. So the- So before using the probe, the precondition will be electronic workpiece measuring probe is inserted into the spindle and activated when you automatically measure the workpiece. So in what scenario we can use this? If the workpiece is not clamped properly. You check the fixture alignment and also to correct the workpiece rotation. And also we can rotate the work offset G54. So the precondition will be so the precondition will be before doing the automatic measurement, connect electronic measuring probe to the spindle. Electronic measuring probe connect the electronic measuring probe to the spindle. And also it should be activated. And also the calibration, probe calibration should completed the probe calibration. And also the return the machine reference. So the procedure will be same. Okay, go to the machine, then measuring workpiece and calibrate probe. So after that, set edge, right? After that, select the again when you press, you have three options: measure only, 0 point offset, and reference, right? So measure only means it will show the value only; it will not save. 0 point offset means the calculated value will stored in the J54 for the proper offset. Then confirm it. So move the probe. So let's take this is the probe. Okay. So let's take this is the probe. So move this probe to the workpiece. So do not touch the probe to the workpiece. Then after that, cycle start. So machine will automatically save P1. Then after that move the say, for example, this is P1. After that, move the probe to P2. Again, press cycle start. then machine will measure P2. If you select measure only, it will show the angle. So for example, 1.85 degree on this spring. If you select 0 point offset inside your machine, it will save the calculated rotation and G54 work offset. This will update. So press cycle start, right? Press cycle start, and then save P1 and P2 and calculate, and then finally save to the selected offset. So what is the difference between manual versus probe? So in manual, we call it as tool scratch method, right? The operator touches P1 and P2, but here it will doing automatically with the help of probe, right? So probe will measure automatically. So in the case of manual, it will depends on the accuracy of the operator, whereas probe will give you high accuracy. Manual method is slower, whereas this probe will be more faster than the manual method. What is R parameters? Right? So R parameters means these are calculation variables. So using this, we can store values, we can do calculations so that uh, we can convert our program into more flexible, and we can use same program for different workpieces. So in programming, we call this R parameter as variables. We call it as variables. So for example, we can take a simple example. Uh, so we have a program where uh, just imagine we have a hole, and the hole position will be X50, Y20. So here the 50 is a fixed value, right? If I can say R1 is equal to 50, I can write X equal to R1, right? Okay. If I change R1 later, we can convert our program into more flexible, right? So as per the manual, we have 300 calculation variables. So we have 300 calculation variables. So R1, R2, R3, etc. Up to 300. And this R parameter is real data type. R parameter is real data type. That means this R can store decimal values also. So this R can store R1 is equal to 25, R2 is equal to 25.5, R3 is equal to 125.876, etc. So this is real. So where you can see this R parameter, go to parameter, program manager, you can see user variables. In the user variables, you can see the, what do you call it as parameters. So let's see, go to menu select, then parameter, right? Yeah, where you can see user variable. So click the user variable where you can see R0, R1, R2, R3. UWM, right? So you can search, say for example, R25. Yeah, so like that you can search. Okay. Okay. Just I will give you a practical example. If I have a hole, okay, so R1 is equal to 50. So in the program, I can write G0 x equal to R1. So machine will store what is the value of x? X is equal to 50. Then later I will change R1 is equal to 80. Okay. that program will execute automatically when you automatically when the program will execute G0 x equal to R1, the value will change to 80. So example 2, so R10 is equal to 100. Okay. So in the program G1 x equal to R10. And later I will change R10 to 150. Okay. Then later when this will execute, the R10 value will be 150. So the main advantage is that what is the advantage of using R? What is the advantage of using this R parameter? So first advantage will be program will be short. So program will be short. And the second one will be we can use same program again and again. We can use same program. We can use same program again and again. Then we can change dimensions very easily. Manual editing very less. Then automation will be easy. Automation will be easy. Then next we are going to discuss setting data. This is to change the machine settings. So we will see the setting data. Go to parameter, click setting data. So here we have in the setting data, we have three main settings. One is minimum spindle speed, maximum spindle speed, and the G96 spindle speed. So minimum spindle speed means this is the lowest RPM. That means it is represented as 150 RPM. Right? Then maximum spindle speed means it is showing us 10,000 RPM. 10,000 RPM. So G96 means constant cutting speed, right? So if this is the diameter, right? So if the diameter is reducing, speed will be increasing. Okay, if the diameter will reduce, speed will automatically increase. Okay. So if the diameter is reducing, speed will automatically increase, but there is a limit. That's why maximum limit is given. Even though the diameter will be small, it will not exceed this limit. Next is what is called a program management or program manager. So program manager. So program management means in a CNC machine, we have n number of programs, right? So we need to store and we need to control those CNC programs. CNC program means it consists of G codes, G code commands, cycles, subprograms, machining instructions, etc. So all those informations, all those instructions will be stored inside this program manager. So go to the menu select and we can see the program manager button. It will automatically open the program list. So go to menu select, then program manager, it will automatically select the program list. And when you open this program list, we can see four different types. Okay, so type, you can see four different types. So one is dir. So dir means it represents the directory or a folder to group the programs. Then we have WPD. WPD means tool directory. WPD represents tool directory to store the tool data. Then MPF. MPF means this is what is MPF means main program. This is the main CNC program. This is the main CNC program. SPF means this is what is called a sub program. Okay, when you see this here, you can see dir. So dir represents the directory to group our programs, right, properly. And we can see WPD, right? WPD, what is WPD? WPD means tool directory to store the tool data. And MPF means main program. So SPF means subprogram. We will call subprogram inside the main program. So as I already told you, dir means this is like a folder. For example, here in this folder, so this is this part programs, subprograms, workpieces. Right? So this represents dir. So WPD represents tool directory. Here, tool data, tool information, everything we can see. So MPF represents the main program. MPF means main program file. So this MPF means main program file, MPF. So this is your, when you run a particular program, it will, so the controller will read this MPF. That means main program file. So for example, click this, open. Yeah, this is the program. So MPF is what is called our main program. Then SPF means subprogram. So this subprogram, so inside the main program, we can call subprogram. So inside the program manager, we can create program. Okay. So how we can create program? So when you click the program manager, you can create a new program, right? So go to program manager. So wait for the previous one. Yeah. This one I'm checking. Okay. So inside the program manager, we can create, delete, copy, change, select or deselect, edit. And also we can save our programs to three places. Okay. So bottom, NC, local drive, and USB. We can save our program either to NC drive. NC drive means this is the machine memory. So we can store our program inside the machine memory, or we can save this into the computer hard disk. And we can save our program in the USB drive. The USB drive. Okay, next, how we can create a new program. So go to program manager. and then go to program manager. So, go to program manager and then click new program. So when you select a new program, you have two options. One is you have two options. One is so you have two options. One is called a shop mill. So shop mill, what is the difference between shop mill and G code? So shop mill means this is like a graphic program and using cycles. Okay, so that means you can see something. Okay, so just select those options so that you can machine the workpiece. So G code. So G code means this is what is called a ISO CNC programming. That means G0, you have to write the code G0, G1, G2, G3, etc. That is the difference between shop mill and G code. Say, for example, here I'm going to select, say, shop mill. Then, uh, uh, okay. So just give the name of the program. Okay. Then after that, you can click accept. Okay. Now you can see now. So this is what is called. We can insert the cycle. So you can select either short mill or you can select G code. So if you select G code, then you can write the code. Then you can write the code. So after that, accept. If you want to add more cycles, you can add more cycles. Okay. Then after that, more cycles. And then after that, simulate. After that, simulate or run the machine. So the workflow will be like this. So the workflow will be like this. Go to program manager and then select a new. From the new, you can select two options, either shop mill or G code. So shop mill means it looks like a graphical user interface. G code means you have to write the code. Okay. Okay. Once you select this, you have to give the name. Okay, and then after that accept, and then program, then save, simulation, and if everything is okay, run. This is what is the basic workflow. So, so, so the flow will be like this. In the case of, G code, you have to write the code, okay? G00, G01, G0, like that you have to write the code. But in shop mill, you have to select different drilling cycle, paste milling cycle, pocket cycle, simulation, etc. Then, if you want to delete a particular program, okay, now you save the main one uh, in the machine memory, right? So first you have to change the program to another program. Okay, for example, select this one, go to where is delete, MC workplaces, spacing them okay, WA to the no, the one to delete. Okay. Yes, so just to delete it. So copy program means you can copy program, you can duplicate one program without changing the original program. So next is select or deselect program. For example, if you need to run a particular program, okay. So to run a particular program, so open the program manager, select the directory, and select the program, and then you have to press the execute key. Execute key. Then the program will be active, and on the screen you can see a green symbol. You can see a green symbol. Deselect. So deselect means how you can remove active program. Then so that's all about what you call the select or deselect program. Next is open or close program. Okay. If you want to see the content of a particular program or edit a particular program, okay, just select the program and then enter. Program editor will open where there you can see the codes. Close program, just back or close soft key. It will back to the program manager. Then coming to the print program. So print program means now you have prepared a program. in your machine. Okay. Next, you will need to take a printout of this. Okay, you have to send this to the printer and take a hard copy. This is for program documentation, student record, quality control, program review, backup copy. So there are three options. One is using file manager, or using ISO editor, or using shop editor. So coming to the file manager means we can directly print the active program. Just go to the program manager, select the directory and press the print soft key. It will automatically send to the active NC program printer. It will automatically connect to the printer. Okay. So the next one is what is called a print with ISO editor. So ISO editor means we will open the G code program. We will open the G code program and then we will print that G code program only. Okay. So this one, how you will, okay, just open the program. So this is our program, right? So this is our program. Then after that, you can click the print file. It will directly print. And the third option will be, print with shop editor. So here, so you have three options to print. So next we will continue program influence. So program influence means suppose you have an NC program. Without changing that operation, we can convert that the running of that program temporarily is what is called changing the method of a particular program temporarily controlling is what is called a program influence by using two different modes such as auto mode and the MDA mode. So program influence functions, we have four main functions. As I have already mentioned in the first session, dry run, M01, SKP, and SBL. So what is the use of dry run? Dry run means we can test our program without workpiece. M01 means this is optional stop. So after executing some lines, it will automatically stop. When you press NC start again, it will continue. SKP, skip block. This is to skip some particular blocks. SPL means you can execute one block at a time. So these are the four main functions, four main program influence functions. So dry run, as I have already mentioned, there is no workpiece, right? There is no workpiece. We can test the program. So axis will move, but spindle, there is no spindle rotation. There is no cutting. So it will check the tool path. The use of this dry run is to check whether our program is correct or not, is any collision. And also this dry run we can use to provide training to the students. So the very important point is that in dry run mode, don't machine the workpiece because speed will change, spindle will off, cutting conditions will not correct. This is only for simulation. M01 means program will stop. If there is M01 command in the program, machine will stop automatically. Okay. If you want to continue, press MC start again. This is to measure the workpiece after completing some operations, check the tool wear, removal of chips and quality inspection. SKP, this is what is called a skip block. Okay. This is to skip some particular blocks. Just give a backslash on the program. This is for debugging, temporary operation, and optional machine. Finally, SBL means single block mode. So machine will execute one block at a time. After executing one line, the machine will stop. You have to press NC start again to continue. This is to study the program, to avoid collision, and also we can test new program. If this is on, it will show on the screen. That means if this button is activated, it will show on the screen. For example, select the dry run mode. Okay, take a program and select the dry run mode and press MC start. Machine will check all the movements. Again, M01, machine stop, tool check, MC start, continue. SKP, skip on, then that block will skip. SBL means after executing each block, machine will stop, press MC start to continue. Next is skip blocks and a single block. So these two functions are used in the program for testing and debugging. skip block means we can skip some particular blocks inside the program. If there is no need, we can skip that block. If there is a need, we can execute it. So this function is very important. Just give a slash in front of the block. So there is escape off button. If this button is off, even though there is a slash, it will execute. Make sure that this should be on. Escape off button should be on. Just give a slash in front of the block. That's it. And after that, go to the machine and then select the skip checkbox on. Make sure that skip checkbox on. And remember, this skip function will work in ISO G4 programs only. In Shopmill, this will not work. Optional development, optional transferring program placement, temporary work. Next is SBL, single block mode. So machine will execute one block at a time. After executing one block, stop. Then press NC start. It will execute the second block. Again stop. Then again stop. Press NC start to continue. This is what is called the SBL, single block mode. Then next we have a block search run. So for example, you have a program. Okay, so you have a program. So N10, N20, etc. You have a program till N500. Okay, machine completed till N250. Okay, till here completed, machine completed. So because of some situation, say power failure or tool break or emergency stop, no need to execute the entire full program starting from N0 to N500. So we can continue from N50. For that, we can use what? Block search option. So using the cursor, okay, and then place your cursor on that block so that machine will internally calculate till N50. If the program is very big, use the text search option to search that block. Then go to automatic mode, select the program. Machine should be in reset state. Select block search soft key. And then you can choose two options. One is cursor position or search for test. So correct program means we already save a program into the machine. So we can edit that program. So the function used to edit that program is called the correct program. So we can change the feed, the speed, correct the dimension, or edit the G code. We can use this correct program. So make sure that your machine is in reset state. If your program is running, you cannot use program edit. So after completing the program correction, you have two options. One is run the program from the beginning and see start, or using the text is search, you can start from the middle, say block number 120. So next is what is called a show G functions. When a CNC program is running, there are so many G codes is working. There are so many G codes working. Some G codes, even though one block is completed, it will be active. That is what is called a modal G codes. Even though that block was executed, but again it will execute in another block. It will continue in the subsequent blocks. It will be active. That is what is called a modal uh, G codes. So this uh, G functions window. So this G functions window means which G code is active, currently active. That window is what is called a G functions. Which G code, which G functions, which function is active. Okay, that is what is called a show G functions. So to see the G functions, go to machine operating area and press the G function soft key. So machine will display all the active G groups. Next is show basic blocks and show running time and workpieces. This is to monitor the CNC program debugging and also the checking the cycle time. Show basic blocks. That means the block right now is executing in the real time. Is what is called the basic blocks. So right now one program is running, right? So real time uh, details about that particular block. So this will help operator to debug the program. So this is very much important because if you have a very large program, okay, so we can check which line machine is currently executed, where is the position of access, which G code is active. So everything we can see in the basic block window. So using this machine blocks, you can see which line is executing right now, where is the access, which G code is active, everything you can see in the basic blocks. Next is show running time and workplaces. This will show the machine cycle time. Okay, it will show the program running time and remaining program time and also the program process. Workpiece counter that shows the how many parts machine. For example, 25. That means 25 parts completed. So when this time measurement will start? When the program start, it will automatically record the time, and if the block reaches M30, then it will stop, or if you press NC stop. If you reset, it will become 0. If you change the feed override to 0, again the time count will stop. Next is count workpieces and show program levels. This is basically related to production monitoring and a subprogram execution monitoring. Count workpiece means how many workpieces manufactured. We can check using this. This will be very much useful during the production time. For example, one day, machine 100 aluminum plates. So once every part is completed, this will count. This is to monitor the production, batch production, automatic production, CNC cleaning, and the maintenance testing. Once one part is completed, count will increase. It will reach us M30. The controller will identify that one part was completed. Or we can use a particular encode to count. So in the screen, you can see what will be the current count and how many parts we have manufactured and what will be the target count. That means how many parts we are going to manufacture. So here go to time counter. Yeah, here is the time counter and program levels. So program levels. So program level means suppose you have a very large CNC program. That means you have a main program, you have a subprogram, subprogram, subprogram. That means consist of different levels. So machine will show which level you are right now. This is what is called a program level. For example, you have a main program, then call the subprogram. Again, it will call the subprogram. So that means machine is in subprogram level. So program level window will show all this. This is to debug large production programs. MCS or WCS switch, machine coordinate system and workpiece coordinate system switch. MCS means machine coordinate system. This was manufactured by the manufacturer. This was fixed by the machine manufacturer. Machine 0 point is based on this. G5455 is not related with the MCS. So it will show the real machine position. WCS means it is the workpiece coordinate system. Operator will define this. To define this using G54, 55, etc. So in part programming, we will use this. So how we can change this MCS to WCS? Check the machine operating area, and we have MCS WCS software. So go to machine operating area. So in a CNC program consisting of a large number of blocks. So editing program blocks means we can edit. We can edit every each block. Mark, copy, paste, cut, renumber, change the circles, etc. Press the exit soft key to go outside from the edit. Search and replace program text. So in an MC program, we have a G code, speed, tool number, etc. We can search one code and we can replace it at once by using the find and replace software. In cycle means in short mill program, every machining operation will be a cycle, such as face milling, pocket milling, drilling, thread milling, etc. This parameter is can change later. Then copy, delete, renumber, define. For example, suppose one particular block or line, we need to delete. So we can use delete program block to delete one particular block. Then we can also renumber that block. We can copy one particular block from one location to another. Define settings means display settings for getting settings. And we have calculator function. Okay, so we can do mathematical calculations directly. For example, workpiece width 120, center position 120 by 260 mm. Directly calculate in the calculator, and we can directly give. If you press equal, it will automatically open a calculator window. If the calculation is wrong, then it will show red color. Calculation will not execute. If you press accept, it will not accept. We can give a formula also. Brackets also we can use, multiple brackets we can use, mathematical operators we can use, trigonometric functions we can use. So backup quitting data means in order to machine a workpiece, we need some informations, right? Machine setup informations. We will save all those informations in a particular file is what is called a backup quitting data. That means tool data, magazine, zero offset, base 0 points, information related to program. So later we can load this and we can use the same setup. For example, in one particular aluminum plate machine, you loaded eight tools, and you use G54 offset. Tool length you measure, tool radius you measure. Next month, if you need the same job, no need to pay this again. You just load this backup file. That is what is called the backup fitting data. So we can save fail data, magazine, 0 points, base 0 points, directly, file, everything. So go to program manager, workpiece overview, select the workpiece, press archive, and then save fitting data. Machine will open the save window. After that, we can save everything, fail data, magazine, 0 points, base 0 points, click OK. So the file we will save as .ini file. So today's last topic was graphical simulation. Without operating the machine really, we will check on the computer screen virtually. See the cutting operations is what is called a graphical simulation. You can see the tool path, machining process, workpiece, result, everything. We can see and do graphical simulation. That means we will not be running the machine. Without running the machine, we will be checking whether the program is correct or not. That is what is called a graphical simulation. Suppose you have written a new program. If you execute the program directly, some collisions will happen, or the tool path will be wrong, workpiece will damage, so tool will break. But it's better to use a graphical simulation. You can locate all those errors. In graphical simulation, yeah, axis will not move. We can see the tool path. We can see the programming error. We can see the workpiece. We can understand collision possibilities. We can reduce material waste. During the simulation, XY axis will not move. Spindle will not rotate. Tool will not touch the workpiece. Everything we can see on the screen only. But before starting the simulation, you should define the size of the raw material. For example, if you are using an aluminum block, what will be the length, width, and height? So the simulation, this size will be using. And also another important point is that work offset. Also set the work offset. Then only controller will know where this workpiece is clamped. And after completing the simulation, you will get an approximate machining time that, for example, 000435 means 4 minutes 35 seconds. So this is not the exact production time. This is an approximate time only. You have 13 main sections in the screen layout, such as active operating area, alarm and notification, program name, simulation messages, access position, tool name, blade number, current NC block, speed or rapid progress, focusing time, start, stop, reset, soft key. Just prepare the program and then define your part, select the offset, and then open the simulation screen, start with the simulation if there is no error, run the machine. While checking the graphical simulation, without running the machine, we can check the NC program virtually. So 3D configuration is we can see the workpiece in 3 dimensions, such as length, width, and height. Normally, we can see 2D view only, but in 3D view, you can see in 3 dimensions, length, width, and height. So that you can see the 3D view of the workpiece, how tool is removing material, you can see the depth of the machine, you can see the collision. Open the simulation window and click the 3D view configuration. If you install 3D simulation license, then only you can see this. If there is no license, you cannot use this. So that's all about today's session. Block by block simulation, that means you can single block, using single block mode, you can execute one block at a time. You can simulate one block at a time, right? Diagnostics operating area means it represents the health monitoring center. Here you can see alarm list messages, the software version, error status, restart option, etc. Maintenance engineer, CNC operator, service technician. So those people, they will be mainly using this area, diagnostics operating area. That's all.